Hi everyone, I hope you're enjoying InfoQ Live so far. I'm delighted to be talking about a bit more about observability in distributed systems and in particular with the high cardinality aspect. So let's jump right in. When we learn how to drive, one of the first things we're taught is to deal with our visibility. And in situations like we see here, driving on a road with a lot of fog and poor visibility is when to slow down. We need to slow down because we don't really know what's ahead of us. There might be a car, there might be something else. And it doesn't mean that we're a bad driver, that we can't drive faster in fog. Actually, the opposite, we know, and we know what we're trying to do. It also doesn't mean that the car is bad. Faster car wouldn't help us in that situation. But on the other hand, if you're looking at the plane, the example of a plane shows that planes can fly through clouds. They don't need to actually slow down. They actually have instruments. They have tools to help them navigate without having to deal with that poor visibility that we have here. And the parallel with the systems that we're building today is we've introduced Agile, we've introduced microservices, continuous delivery, a lot of things that actually can link themselves to building a faster car, but not really actually thinking about where we're going. And this is observability for me. This is how we're actually focusing on really building things faster and building things that are more prone to help us deliver feature faster. But ultimately, if we don't really look where we're going, we're going to be in big trouble. So who am I to talk about this? My name is Pierre. I'm head of SRE at a company called Glowfox. And throughout my career, I have spent the first decade of my career being a software developer. And over the years, I got more and more interested in actually how do applications reach production? And once they're there, how do we know what they're really doing? And that's the reality of production is this is really only the beginning for the applications that we're building. It took me a long time to realize this as a developer or as a software engineer. For me, for a long time, it was I pick up the story, I write my code, I commit the code, and that's the end of the story. Now I move on to the next thing. Production was this magical land that ops were dealing with. Occasionally, I might be, given a couple of log lines, say, okay, what's this happening in prod? Do we know what it is? But that would have been pretty much the limit. That kind of magical land. And okay, things have gotten better in the last, while. We've pushed more and more efforts into testing, into getting things getting things in a better place before to reach production. Unfortunately, we still spend most of our time before production. We don't really have that attention to detail as to, okay, now there's real users into our systems, what's really happening. And that's really important because when we only focus on things like testing and thinking that we can build the perfect system, then we're actually under the illusion that we can build the perfect system. And actually, this is not true because not anything that we're going to build is going to be immune to fail in one way or another. And if we are under that illusion that things are going to be keeping to work, if we're under that illusion that we can build that perfection, then we're going to be in big trouble when it fails. Instead, what we have to be is we have to be comfortable with that failure. We have to be ready to figure out, okay, why is it failing? What is failing? How can we recover? How can we mitigate those problems and so on? And observability is one part of this, is how do we understand all of those situations that even if we have tried really hard to make things not to fail, when they fail, okay, what tools do we have at our disposal to figure out what it is? And that's true for any kind of system. But as we've, I suppose I've said it a couple of minutes ago, when they're in the last few years with introducing things like microservices, service-oriented architecture, we're distributing our systems in cloud services, in multiple databases, with clusters, with you name it, containers, and so on. That's great. That's helping us being a lot faster to develop. That helps us scaling our teams. That makes things easier for developers to, reason in local context to build things. But we have the paradox that now we're making things a lot harder to operate. We're distributing the places where things may start to fail. They might start to fail in many different ways. Things might start to fail in between components in the network and so on. And so we're actually in a much more precarious position now that we're thinking we have simpler things, but essentially we need to know a lot more about our systems. So knowing about systems in production is that just not monitoring. Okay, there's an eternal debate, monitoring, observability, are they not the same thing? Well, they are not the same thing because monitoring is only about the things that you know about. They're only there's going to be only a subset of failure mode, a subset of things saying, okay, I know this is not under my control. I know that I want to be told when this is failing in this way. Essentially, my website is up or is it not up? Or I have a rate of errors on my API, or my database latency is, over that certain amount. But everything else, which is the things we don't know about, so it's that split between the known unknowns you're monitoring, coverage of known unknowns, versus everything else is anything that you don't know that is going wrong in a way that you never imagined. And that's where observability shines. It's those things that you can't think about before they're going to happen or before you're going to need to ask your system about. So if monitoring is not the things, what about all those three pillars? We've talked that to that over the last few years is, okay, we have metrics, we have distributed tracing, we have logs. Those are really useful. Those are really useful concepts. But they're only different ways to look at the same thing. Like metrics is, numbers about things that happen. Traces is looking at things correlated over time. And logs is kind of like, okay, I just want to look at the raw thing. They're all derivatives of another concept that happens way before that, is the events. And I'm talking events with high-cardinality dimensions, which allow us to derive those metrics, those traces and logs. So I said events, for me, they're the core thing that happens for observability. Something happens in your system, an event is emitted, it's recorded somewhere, and it has a lot of information about the deep context of that event. From that point, we can get to those three pillars, or like those visualization, if you will, of those events. So if we aggregate those events, we can get some metrics. We aggregate them over time, we get some time series. If we correlate them between each other, so that event happened, that other event happened, they're related, we can get some form of distributed tracing with things that kind of an end-to-end view of a request through multiple services, for example. And we might want to just do a bit more kind of heavy analysis on those events, and they could be raw events, or they could be indexed. So you can imagine something like Elasticsearch or something like that, that just gets you something that is a little bit more exotic to analyze. And so I'm saying high-cardinality dimension. What do I mean by high-cardinality? High-cardinality dimension is essentially a field that has many, many possible values. And those fields, they're the things that provide you with that really rich context that you need to explore those unknown situations. And by like many possible values, there could be like even unique values, or they could be user IDs, they could be IP addresses. And this is the type of thing that doesn't really typically work for something like metrics, for example, because if anybody has tried to put something like IP address in a Prometheus label, you know what I'm talking about. It's just not going to work, and it's probably going to blow up, or it's going to be really slow. So that's the real power here of getting those events and then derive it to something, instead of having only focusing on, say, metrics as the primal order. So what does that look like if we're looking at the kind of the spectrum of known unknowns versus unknown unknowns? So I mentioned metrics, I mentioned traces. Like on the known unknowns, there, okay, again, the things that may go wrong, but we know about. we're kind of conscious those things may run in certain ways. So health checks, that's the most basic thing. Is something up? Is it up? Is it working? Is it not working? The further we actually go, we might have something like synthetics that just tell us more about a symptom versus of something happening. Then we have our application performance metrics or metrics time series. And the further to the right that we're going, the further the power of actually asking questions about what's going on. Then we have distributed tracing that gives us a visibility of things over time throughout our system. Then we have things like logs and finally events with high-cardinality dimensions. And the reason I'm putting them all the way to the right there is because they are the raw information that most of the time can actually be derived for anything that we actually see on the left. Those known unknowns on the very left, they are still useful. Don't let somebody tell you, okay, APM is dead, or health checks are useless, or metrics are bad. Those things are useful, but the more to the left we are, the more we are in the monitoring space. We are in the kind of resiliency and automation. This is stuff that's useful for machines, stuff that's useful for auto scaling, for self-healing systems. When we go to the right, then we think about ourselves, so people, humans, intuition, kind of muscle memory, explorations, all of that stuff that we need when we reach those unknown unknowns, those situations we had no idea could happen. And now it's up to us to figure out what's going on. This is that exploration that cannot be automated because we're talking about kind of unpredicted situations. So let's look concretely, what does that look like to have high cardinality? You might have seen something like a type of logs like this. So error, read timeout, and a timestamp. Like, I'm pretty sure anybody that worked on logs has seen something of that type. And usually it's like, thanks, but that's not super helpful, isn't it? How can we raise this error? How can we raise this log entry or this to an event that provides that rich context? Well, that rich context can first include some of that information. So like, we already have this. When did it happen? We have a timestamp. Then what is the message? Okay, we know that's an error. It has a log message that's okay. Arguably not super useful, but read timeout. And then we can add contextual information about what it is. So what service did this? What team? So maybe the registration service for something like events. So maybe we have a team that's managing event registration. And what service, what actual runtime was running and caused that error? What's the commit number? What's the build that generated that container image? What's the runtime inside that container image or inside that server? And where is it running? Is it like, do we have a particular region? Is it running on, I don't know, a specific node inside some kind of orchestration cluster? Who caused it? Who was affected by this problem? Is there a specific customer? Do we have a user? And now we're getting into really high cardinality. I mentioned, a high cardinality dimension is something that contains many different possible values. So customer ID, user ID, a commit number, you can't get any more random than that. And that's going to change quite often. And then we have the information that we might need to correlate these things together, a trace ID, a spine ID, correlation ID, or request ID, you name it. These things are also random and just highly, there's a high entropy to them. And any other info at that particular point that is useful for that event. And by useful, I mean any context you have. Like, this is literally just fields, arbitrary fields with arbitrary values. When we are logging something, let's log as much context. And then what we do is we encapsulate all of this information and set it out as JSON or some format. And now, from those very, very poor logs, what we have is structured logs that are essentially considered as events. And then we can send them to something that's going to help us be more powerful to ask questions to the system. So what does that look like if we're sending those events to a system that allows us to ask those questions? So that exploration power is really like it really becomes apparent. Like for if let's say we're sending those events to the Network stack, so we have Kibana on top of Elasticsearch, and here this is a real graph from a situation here where we had a spike of requests that happened, and this is actually grouped by customer ID. And so you can imagine here, if you don't have your customer ID, which is a high cardinality field, all that is just kind of one color, and it's very hard to figure out what's going on. In this situation here, we can actually drill down to that particular color and actually see, well, there was no activity for that customer before 5 o'clock. And we can see that, okay, this spike can be isolated for a specific single customer. Without the high cardinality, this is just kind of one kind of solid color graph. And we're not any the wiser to say, actually, maybe this customer is doing something weird, or maybe we just signed them up and actually this is okay. Another way of looking at this is when we do releases. When we do releases and we want to include that build version as a high cardinality entry, then we can isolate those different events over time, depending on their build version. So, like, for example, in that situation, the error rate is spiked only on a specific version. The other version was fine. So it shows us during some kind of progressive rollout or a canary deployment that, okay, a specific version was causing a lot more errors. So this is looking at this by figuring out what's going on and just kind of trying out a few fields and looking at that. We can also flip that that aspect and use those high cardinality field in kind of a semi-automated way of figuring out what is different. And I'll just show you an example here of something that actually I took this afternoon, and showing us the distribution of of requests over time. And we can see from that heat map, there is a section here in that heat map that looks different. And so like this is using a tool called Honeycomb, and Honeycomb is able to kind of slice that and show me, okay, all those high cardinality fields that I've specified, what looks different about that highlighted area. And I can actually see that, okay, throughout this time here, we had Stripe webhooks that were causing slower requests. And that's really useful because now I have that awareness of, okay, now there's common characteristics for things that look that look like outliers. Before that, without that information, all I would have seen is potentially an average request type that would have been like essentially not super useful. We would have known, okay, we have slower requests, but that's as far as we go. And look, there's nothing like a real life example to really drive down the power of the high cardinality aspect. Is I think that was last year around June, I believe. So last year was obviously a bit of a tricky year for any business. And at Glowfox, so the company I work for, we are building software for gyms and fitness studios and so on. So you can imagine the last year has been interesting in terms of closures of the fitness industry and gyms essentially opening and closing at different times in different places of the world. And so what we've seen is I think around the end of June, we had synthetics failures that started coming in, and we realized that our API actually came to our API. We got alerts saying, okay, API is not reachable, or API is not responding on time. So from that point on, we started, so obviously triggering incident response. We go and look at the system, and we see, okay, it looks like there's a lot more requests than usual coming in. There seems to be spikes now since 6 p.m. That's that seems weird. So we looked at our scaling. So okay, the auto scaling is kicking in, but that doesn't even seem to cut it. So we started scaling a little bit more, trying to mitigate. And then we started becoming a little bit worried because we're like, okay, how come our request rate is, 5 times what it normally is supposed to be? Like, we started really, looking at each other, just go, are we kind of under some kind of attack? Is it some kind of DDoS going on? And so then we started digging into the events a little bit more of what we had in our system. And we started looking, okay, where are those requests coming from? If it's some kind of denial of service, maybe there's 1 or 2 people we can isolate. And no smoking gun there. We look at IP addresses, and so IP address being high cardinality field. We see a bunch of IP addresses, but nothing really damning there. What we see though is like all of those requests are actually coming from Singapore. And it's like, okay, country, that's high cardinality field as well. So we can figure out, okay, those requests are all coming from Singapore. We just correlate that with the IPs. Yeah, it looks like this is all coming from Singapore. Weird. Okay, we have a lot of customers in Singapore. Then we figure out from the incident channel where our customer experience people were, and they just tell us, yeah, well, Singapore is coming out of lockdown today. And we have many studios here from that same franchise that are reopening, and they're reopening their bookings for everybody, and they're doing it now. So like, okay, that seems like it's right. But look, 10 gyms reopening at the same time to book classes, that doesn't seem like something that would bring down our APIs because we have thousands of gyms. Why would these 10 now suddenly cause a problem? So we started digging a little bit more, and it's like, okay, there's nothing different here. And then we realized that one of the fields that we were actually exposing in our events is the versions of the front ends that are being used. And what we saw was like a big light bulb, and essentially we saw that all of those requests were coming from gym studio receptionists that were after logging back into their system and were running a 3-month-old version of our front end. And funny enough, we had flagged probably a few months back that if you leave the front-end application running for a number of days, it starts getting slower and slower. What happened is those gyms had closed back in March, reopened in June, and they just logged back into their computer with the tab left open with a web app that was actually running for 3 months. And that bug was actually, the reason that the application was slower is because the bug was actually creating a really, really, really long loop of watchers and continuously querying our API. So what happened is we had essentially 3 months of kind of requests queued up in some applications that got reopened, and we're hammering our API. And so here we were actually able to say for sure that those requests were coming from a really old version, not of our API, but of our front ends. And we're able to kind of shut this down by releasing a new version of the front ends, forcing the front ends to re-upgrade and fix that problem. This was like close to the most puzzling problem that I've had to look at. And without those high cardinality fields or dimensions that we had in our events, I think it would have been pretty much impossible to figure out. And to me, that really, really points out the type of stuff that's like, it's pretty much impossible to predict that kind of thing would happen. Like, you're not going to monitor for it. You're not going to be alerting on it. You're not going to have synthetics and that kind of stuff. When you look at it afterwards, you're like, oh yeah, okay, that was easy. But when you're in the middle of it, you're like, okay, I'm really glad I have all these fields. I'm really glad I have all these values, because these are questions I never thought I would ask, but I'm really glad I got answers for. So that's me for today. Thanks a lot for joining, and I think I'll be taking questions now.
Can you hear me?
I can. Yeah. What's this time?
New headset for me today, and that's lesson number 1 is don't get a new headset before an important day. Yeah, I love the session. Thanks, Pierre. Yeah, a couple questions I'm going to get to in a second that are kind of related to one of mine. I want to know who's responsible for providing the high cardinality. Is this problem for each of the dev teams to put in the data, or is it something that the platform, the SRE teams, and somebody else takes care of and just is able to slap on?
I think, well, like a lot of questions, the answer is it depends. Like there are things that we obviously want to have common across different contexts for things that will make sense for any type of requests or any type of events. And for that, the responsibility for the instrumentation remains on the teams, but the agreement on the standard of, say, like naming conventions and what type of things as we put in events, that's like more ownership on the SRE side, saying, okay, we want to try and instrument things all the time with a customer ID or a user ID, and this is what the field looks like, and this is what kind of value we want in there. Then the teams themselves have the freedom to say, well, in that particular event, there is that context that makes sense to me, and that only makes sense because, okay, this is what my system does, and this is what information I have at my disposal at the time this event is happening. So, like, by all means, it's, yeah, put it out there. It's not going to be relevant for other teams, but when your team is going to look at it, that's going to be interesting. So it's kind of a consistency piece for things that are common, and then after that, the teams are responsible for what makes sense.
And so what's the full technology stack that you're using? What do you use to help write those events in a consistent way? And then you mentioned Honeycomb and Elasticsearch and Kibana. What's the outside of it?
Well, like, to be honest, for us, that's a thing that's very much in movement at the moment. Like I've worked on slightly different tools in different places, and I would have done quite a bit of work with Elasticsearch previously, and just, I suppose, indexing fields like that with Elasticsearch. Right now, in GlowFox, we do we're an AWS shop. We did a lot of stuff with CloudWatch, and even using tools like CloudWatch and CloudWatch Insights, which a bit rough around the edges, but actually can do the job for that kind of stuff, ingesting arbitrary data, being able to write queries to summarize and aggregate that data without the data loss that an APM tool would have, for example. So there was a question in the chat there about Prometheus. Prometheus is brilliant, but if Prometheus is your starting point, then by the time data made it in Prometheus, you've lost information. If we start at events with arbitrary data in logs, and then we summarize from there, then, well, we have all the information there. And we've been working more recently with Honeycomb, and, well, I suppose Honeycomb is, I didn't know they were a sponsor today, so, and I don't have the shares in there, but I really love the tool because it just puts another layer on top of that from, like, a really good user experience to do these things, and shape that data really quickly. So that they're the kind of tools in our stack for this.
Yeah, and I think you had a slide that kind of had the spectrum of here's the raw events to here's the monitoring. You described it as the stuff on the left was for monitoring resiliency, the system's able to self-heal, and on the right side you got to debugging and exploration. So I'm wondering, this is very useful for the troubleshooting. Have you guys used it for doing any sort of performance tuning or any other kind of experimentation observing the system?
Yeah, I mean, I suppose performance tuning, I would probably qualify that as some performance troubleshooting as well. And it's like when we're looking at our service level objectives and these kind of things, being able to pinpoint, okay, what doesn't make our SLO, for example. It's like if I'm looking at, okay, what are the requests that are slower than my threshold, and starting to look at those high cardinality fields, saying, okay, well, is there something sticking out? Can I kind of cluster those particular, failing requests or those slow requests, and like several occasions being able to say, actually, usually it's not random. There's always going to be, hey, look, 20% of your requests that were slow, they're all on this endpoint, or they're all from this specific customer, and that's that's information that gets buried in averages if we don't have that data.
Yeah.
Like in terms of experiments, just you mentioned experiments as well. Like that's it's the kind of same power as well. Like if you tie that in as to, like, so running experiments can be tied to feature flags and kind of I suppose beta segments or groups of users, anything like feature flags can be considered as high cardinality information as well, and can be tagged into events, and then start doing a kind of an A/B test versus, hey, if you had the feature, if you didn't have the feature, what's actually happening. So that's kind of the beauty of it. You can put whatever you want in there.
Right. And that's what I wondered, is if you not only can help it run the experiments, like get the clear, separate the A/B, but can you use it to dive one level deeper and figure out maybe why an experiment had an outcome? Like, we saw this correlation between the A versus the B, but also people on a Mac reacted differently than people on a PC versus on a phone or something.
Yeah, like we haven't really used that at that kind of level. I guess selfishly looking at my world more in the infrastructure side, where because my silos are like on performance and these kind of things. So that'd be my main focus. But I think that's a really interesting way to explore that, and there's going to be some overlaps in tools as well. Like, if I suppose feature flagging tooling and experimentation solutions would kind of try to provide that as well themselves, to try and correlate these things. But yeah, something to try, actually.
Yep. Yeah, it's nice that it gives you those options now that you have the high cardinality data. You can do different things with it. One of the questions from the chat was about privacy, that if you're using a user identifier, how do you handle anything that might be able to tie back to the user all through your logs? Yeah.
I suppose that's the eternal challenge there of how much information we can have and we can handle in tools for privacy. Now, I suppose if we're talking about things like GDPR or kind of privacy regulation things, I suppose remember that with GDPR you can use as much of the information that you need to operate your system and provide your user with a product and with value. So if you consider that data is actually valuable to provide a service to your users, and if you have clear retention policies, that this is going to be gone, that you have kind of clear, right to be forgotten type of approach, of saying, well, okay, but after 30 days, we know that data is gone, or if we have a way to clean up the data, then that's fine. If you don't, then it's kind of self-regulating and saying, well, these are the kind of fields we don't want to put in there. So like, you don't want to have API keys, you don't want to have passwords, that goes without saying, but maybe you don't want, I don't know, maybe you don't want IP addresses because these are considered PII. Maybe you don't want first name, last name, email addresses. There are ways to kind of go back to them. You can kind of use like hashes. Like, sometimes the most important thing is kind of clustering things together to understand their the fact that they're common. But ultimately, if you have some bug that's related to the fact that the first name starts with the letter A, you will have to have that. I don't know if that ever happened to anybody, but that's this is going to be a trade-off. I would say it's my take on this is, if this is data that you think you need to operate and provide service, then it's okay to have in there. Now, just be careful with your data privacy agreements and like third-party tools if you don't run them yourselves.
And then one of the other things I know people are concerned with when you start collecting all this extra data, you have all the high cardinality, but that packet of JSON you were talking about, that can grow pretty big, and then you're capturing potentially millions of those packets that are very large. Do you have any concerns about storage? Do you have an archive policy that we drop data after, like you said, 30 days, just to keep from growing too big?
But honestly, we haven't had too much of a challenge with that, and we have like hundreds of millions of events on a monthly basis. Now, like, we don't have trillions of events. We're not like Bianca, we're not the BBC, where there's potentially petabytes of stuff. That's potentially other challenges. If it approaches those types of levels, then sampling is like I suppose a bridge to cross on saying, well, maybe we don't want to record everything. We want to kind of dynamically sample and say record the things that are outliers, and otherwise, if it's within the boundaries, if it's successful requests that are quick, for example, maybe we only need to send 1 in 100 or these kind of things. suppose my experience in this over the last while is like storage is relatively cheap, right? I mean, it's out of all things, you know, Amazon will charge you for data transfers, but storage is not really that expensive. If you have right retention policies and yeah, and you don't have the kind of trillions of events type of scenarios, like so far it's more, I've more seen that as a theoretical problem rather than a practical one.
Right. And it's one of those, don't pre-optimize, right? Don't start throwing stuff out. Like once it becomes a problem, then you can deal with it. And that's
100%. Yeah,
a good approach. And I like the idea that you said this is key to your business when we were talking about the privacy. Like this isn't some add-on nice to have. Like this is key for operating your system. You need to have this amount of data and events stored so that you can actually successfully run your business. And then it becomes a business concern. I'm trying to see if there's any more questions in the chat. I wanted to go back to the analogy you gave at the beginning of a car driving through the fog versus an airplane. I think it's interesting that you said that the airplane can do all this stuff because it's got the instrumentation, and then in a car you actually have to slow down. Because I think of airplanes have, you know, a multitude of sensors beyond a car, and that's kind of how these systems become, is you are intaking all the data, but someone still has to be able to summarize that and aggregate it. So I think it does kind of play to your idea of we have all the data, and then if we need to dive in and do more analysis, we can operate in the fog, so to speak. Do you feel like you're operating in the fog a lot of the time, or is it mostly clear sky and then you only need all this data when you enter the cloud?
Yeah, I think there's multiple levels. I think there are starting points. They're like, and that's why I think I said, like, around the APM stuff, I wouldn't just throw the APM world out in the bin just yet. I think I know GlowFox, we're using CloudWatch for metrics, we're using New Relic for some things, and it's like you can still use those things for like high level signals. Like you're not going to be staring at high cardinality all day, because they're there to help you figure out like those outliers, those things that you didn't really plan for. Like they're good for like taking an hour exploring the data. Like I love this, just going into there saying, okay, there's a couple of spikes here. I'm just going to dig in a little bit and learn more about my system. But most of the time, you don't have the time to do that. Like it's so you have to rely on high level signals, and when those thresholds or SLOs are kind of breached, then we have the tools to look at it more. I assume, like I have the analogy of the plane. I'm not a pilot, but I assume they're not staring at every single dial throughout the entire flight. But then there are signals and alarms of things like, okay, something's going wrong. Now there's a couple of things to look at, and I have that in front of me or at disposal, or so on. So I think it's layers. Like dashboards are important to have starting points, and then start diving into asking questions. But we're the only ones with our brains to be able to ask those questions. Most of the time, that automation is going to work for building those dashboards and have alerts to a certain point. After that, it's kind of an exploratory mindset, and I think we're still better than machines at doing that.
Yeah, I think that's why we call them dashboards. The same reason we call it dashboard in the car. It's got your speedometer on it. It's got like the thing you need to know right now. I think we're coming up right at the limit on our time for this session, but there will be a follow-up informal Q&A. So if you want to continue the conversation, the link just popped up in the chat. You can also get to it from the session page. So feel free to click the link, join that Zoom conversation, turn on your camera and mic, talk to Pierre some more, ask me further questions. There's a couple questions we didn't get to that popped in right at the end, so we'll be sure to ask those. So a final thank you to Pierre Vincent and everyone for attending the session. Hope you enjoy the rest of InfoQ Live.
Okay, thanks, Thomas.